2021 on Smart Agriculture for Green Planet. The ceremony is taking place virtually due to unwanted COVID-19 pandemic situation. We're very delighted to have the presence of the SAIYN advisors, mentors, and ambassadors, distinguished researchers and academicians from the universities of USA and Bangladesh, participants of the SAIYN Idea Competition 2021, university students, distinguished guests, ladies and gentlemen, very good evening to all of you again. We hope that you will be with us until the closing of the program. Some housekeeping announcement. Please keep your microphone mute until you speak in the session. If you have any question or suggestion during the program, you may put your question in the chat box. You may turn off your video for better streaming or saving the megabyte of the data if you are connected via cell phones. The meeting is being recorded, so there should not be any problem from your side. In this grand finale, we're very glad to have Honorable Vice Chancellor, Professor Dr. Lutful Hassan Sir, Bangladesh Agricultural University, Mymensingh, as chief guest, Dr. A.K.M. Zakir Hussain Sir, Students Affairs Advisor, Bangladesh Agricultural University, Mymensingh, as guest of honor, Dr. Prashanto K. Kalita, International Advisor, SAIYN, Director, Appropriate Scale Mechanization Consortium, ASMC, and University Distinguished Professor and Presidential Fellow, University of Illinois at Urbana-Champaign, USA, as guest of honor, Dr. Muhammad Nazrul Islam Sir, Dean, Faculty of Agricultural Engineering and Technology, Bangladesh Agricultural University, Mymensingh, as the session chair of the grand finale, Dr. Muhammad Manjur Alam Sir, Chief Advisor, SAIYN, Project Director, ASPI Bangladesh, Phase 2, and Professor, Department of Farm Power and Machinery, Bangladesh Agricultural University, Mymensingh, will give us the welcome speech. Now, with permission of the chair, Dr. Muhammad Nazrul Islam Sir, I would like to start the grand finale of SAIYN Idea Competition 2021.
Okay, carry on.
Thank you very much, sir. Now, Professor Dr. Muhammad Manjur Alam Sir, Project Director, ASPI Bangladesh Phase 2, and Professor, Department of Farm Power and Machinery, Bangladesh Agricultural University, will deliver the welcome speech. It is my great pleasure and privilege to invite Professor Dr. Muhammad Manjur Alam Sir for his welcome speech.
Thank you, Masroor. Honorable Chair of this grand finale of the SAIYN Idea Competition 2021, Professor M.D. Nazrul Islam, Dean, Faculty of Agricultural Engineering and Technology, Bangladesh Agricultural University, Mymensingh. Honorable Chief Guest, Professor Dr. Lutful Hassan, Honorable Vice Chancellor, Bangladesh Agricultural University, Mymensingh. Honorable guests of honor, Professor Dr. Prashanto K. Kalita, Director, Appropriate Scale Mechanization Consortium, and University Distinguished Professor, University of Illinois, Urbana-Champaign, USA, and Professor Dr. A.K.M. Zakir Hussain, Student Affairs Advisor, Bangladesh Agricultural University, Mymensingh. Honorable Advisory Committee members of ASPI and Philil Bangladesh projects, SAIYN advisors, SAIYN national and international mentors, SAIYN ambassadors, BU colleagues, distinguished participants of Idea Competition, dear students, representative of print and electronic media, ladies and gentlemen, very good evening to everyone and very good morning to our colleagues from USA. Dear participants, I'm very delighted to welcome you all to this grand finale of the SAIYN Idea Competition 2021 on Smart Agriculture for Green Planet. I presume that you have had an introduction to SAIYN. SAIYN, a Smart Agro-Technology Innovation Youth Network. SAIYN is a knowledge-based learning platform for youths where they can explore and push their interest on smart and innovative agro-technologies for sustainable agricultural production, processing and marketing to ensure food and nutrition security of the globe, especially in Bangladesh. This network is formed in connection with the 4H Illinois approach through the project Appropriate Scale Mechanization Innovation Hub Bangladesh, a core component of Appropriate Scale Mechanization Consortium at the University of Illinois at Urbana-Champaign, USA, and financed by the Sustainable Intensification Innovation Lab, SAIYN, Kansas State University, and the Future and USA. Ladies and gentlemen, you will be happy to know that SAIYN had launched an idea competition among the youths in Bangladesh and have received about 19 ideas. Those ideas were evaluated by a panel of national and international judges and came up with a short list of 10 ideas. Today, we are going to enjoy the brief presentations on these ideas, and through your further assessment, 3 winners will be identified for award, and all 10 ideas will be recognized with appreciation certificates. I would like to acknowledge and extend my sincere appreciation to the youth participants and their mentors from different universities of Bangladesh for their participation in this idea competition. I especially like to thank to the national and international judges for their valuable evaluation of the initial ideas. Ladies and gentlemen, let us extend our sincere appreciation and encouragement to today's competitors, the youths on whom the future food and nutrition security of Bangladesh and the mankind at large depends on. Thank you everyone for listening to me. Thank you all.
Thank you very much, sir, for your wonderful welcome address. Our chief guest of the grand finale of SAIYN Idea Competition 2021 session is Professor Dr. Lutful Hassan, sir. Professor Dr. Lutful Hassan, sir, is the Vice Chancellor of Bangladesh Agriculture University, Mymensingh. It is my pleasure to invite the chief guest to deliver his speech now.
Yeah, thank you so much, Mashur. Honorable guest of honor, Prashant K. Kalita, the Director of Appropriate Scale Mechanization Consortium, University of Illinois at Urbana-Champaign. Special guest, Professor Dr. A.K.M. Zakir Hussain, Student Affair Advisor, Bangladesh Agricultural University, and Professor Dr. Monjurul Alam, the Project Director and Chief Advisor, and Professor Dr. Nozrul Islam, Dean Faculty of Agriculture, and the President of today's meeting, and affectionate contestants of SAIYN Idea Competition, SAIYN ambassadors, guests, and candidates winners of the SAIYN Competition 2021, and other dignitaries, those who are attached today with this international event and national event. I am really very happy to express my gratitude over this, that the winner of SAIYN competition, those who has worked here and make this competition a successful one. And not only that, they produced the ideas during this era of fourth industrial revolution, and they got some smart ideas. And of course, this sustainable agricultural production system will help in due to the development of these smart ideas. Not only that, I'm very much happy, and I would like to express my gratefulness to the organizers, particularly the USA team and the Feed the Future, USAID, SEAL, and the another organization is with us, that is Bangladesh Agricultural Research Institute, Bari, and the ACI Motors, the private sectors. All these are involved into the system. So I'm really very much grateful that we are working, particularly the Bangladesh Agricultural University, we are working very closely in collaboration with this USA team, particularly from the University of Illinois, Urbana-Champaign, and then Kansas State University, and then SEAL Project, and then USAID, and all these collaborative partners, along with the Bangladesh Agricultural University. So Bangladesh Agricultural University is now looking forward for their collaborative partners for the development of the university and for the development of the country. And not only that, Bangladesh Agricultural University is working hard to attain this sustainable agricultural development goal to achieve, so that the Bangladesh can achieve sustainable development goal by 2030. And Bangladesh Agricultural University is working with all these stakeholders, those who are involved today. And you know very well that within the system, we need to have the involvement of the youths and the females. Particularly, we would like to share our ideas. These are smart ideas from this SAIYN competition. Male and female candidates were there, and the young chaps, they are the future of the country, you know very well. Youths are the future leaders for achieving sustainable development goal. And not only that, sustainable agricultural production system is really, they are the leaders. So we need to develop them through this type of training, through this type of arrangement, through this type of programs. And we are highly organized. And I would like to extend my thanks to Dr. Manjurul Alam, along with his team, Dr. Chayan Saha, and the other involved person, and also the Dean of the Faculty of Agricultural Engineering and Technology, Professor Dr. Nazrul Islam here at home. And from abroad, of course, our friend, real friend from United States, University of Illinois, is the distinguished professor over there, and the Director for Appropriate Scale Mechanization Consortium, Professor Dr. Khalid. And I hope that all the stakeholders will work together to achieve the goal. And particularly, you know, today in this session, our Student Affairs Advisor, Professor Dr. AKM Zakir Hussain, is attached with us, and he is over here as a guest of honor, and he will speak about this occasion also. And because he is the Student Affairs Advisor, it is his domain that how these young folks, particularly the students of masters, PhDs, or undergrads, everybody, how these people could be involved in this type of activities like SAIYN ideas, and then these smart ideas from these young students and the involvement of youth. So his statement will carry much weight, and he will encourage the students. Particularly, I am very much happy that that all the students, those who are actively participated in this competition, and they came up with new ideas, and their ideas will help us during this era of fourth industrial revolution. That's what we are now continuing. So I'm a little bit busy. That is why I'm unable to be with you. But dear students, your affectionate students at Bangladesh Agricultural University and other stakeholders, I am always with you, and I would like to extend. And we are committed to organize, and we are committed to help any situation, and particularly this type of project led by Professor Dr. Manjurul Alam and Dr. Chayan Saha. We are really committed to help extend all sorts of cooperation to the local team and the team abroad and our USA friends. Thank you very much, ladies and gentlemen.
Thank you, sir, for your deliberation and encouraging speech as always. Now, at this moment, Tanjima Akhtar, SAIYN Ambassador, National Affairs, MS student, Department of Farm Power.
Dr. Champok, Dr. Munjurul Alam, I am leaving now.
Yeah.
Okay,
Okay.
sir. Thank you, sir.
Thank you very much, sir.
Thank you, sir, for being with us. At this moment, Tanjima Akhtar, SAIYN Ambassador, National Affairs, MSc student, Department of Farm Power and Machinery, Bangladesh Agricultural University, will deliver a brief overview on SAIYN.
Thank you, Mashur Ahmed Bhuya. Now I'm presenting a short presentation overview of SAIYN on behalf of SAIYN ambassadors. It's Tanjima Akhtar, National Affairs Ambassador, SAIYN. So good evening and good morning for our guest from USA. So welcome to my presentation. This is the outline of the presentation, and I'm talking about all the point of this presentation in briefly. SAIYN. Basically, if you break the name of SAIYN, we got S for smart, A for agro-technology, I for innovation, Y for youth, and finally N for network. Basically, SAIYN is the youth-based network platform where they can explore and boost their interest on smart and innovative agro-technologies to ensure food and nutritional security. SAIYN is established in May 2021, based at the Department of Farm Power and Machinery, Bangladesh Agricultural University, Mymensingh, Bangladesh. The origin of this organization is the Project Appropriate Small Mechanization Innovation Hub, ASMI Phase 2, Bangladesh, with the collaboration of University of Illinois at Urbana-Champaign, financed by the Sustainable Intensification Innovation Lab, Kansas State University, and Feed the Future, USAID, USA. SAIYN has the vision. The vision of the SAIYN is to connect teenagers and youth around the globe, to engage and empower them for a positive agricultural transformation. So SAIYN has 5 missions. SAIYN connects teenagers and youth through networking. It engages youth in a meaningful way. It empowers young people through capacity building events. SAIYN creates an entrepreneurial culture among youth. And finally, it seeks partnership and collaboration to work. SAIYN always follow 4H stance. Its meaning, the first H is the head to clear thinking. Actually, the head to clear thinking to learn new things through project and improve life skill, including leadership, responsibility, dedication, communication, and self-confidence. The second H is heart to greater loyalty. It actually means to take responsibility of their projects and maintain a positive relationship with adults and teenagers. The third H is the hands for larger service. It importance of serving the community, country, and the world. The final H is health to better living, and it's ensure youth are physically and emotionally safe. By putting all the H together, we get a 4H players. That was head to clear thinking, heart to greater loyalty, hands to larger service, and health to better living. With the collaboration of all H, we got 2 slogans of SAIYN. The one is English and one is Bangla. The English one is think great, do great, innovate for green planet. And the Bangla one is Torner Medha O Shokti Gorbe Shobuj Prithibi. The base station is situated at the Department of Farm Power and Machinery, Bangladesh Agricultural University, Mymensingh, Bangladesh. SAIYN has an organization structure that was Chief Advisor, National Advisor, International Advisor, National Mentors, International Mentors, Campus Mentors, and finally core ambassadors with Chief Coordinator. Under the Chief Coordinator, there are core ambassadors and campus ambassadors. SAIYN initially formed 11 members advisory panel in national and international, a 9-member monitoring board in national and international, 12-member monitoring board in regional, 11-member ambassadors, and 20-member campus ambassadors in regional. At the behind of the scene, there are 8 universities worked for SAIYN. That is Bangladesh Agricultural University, Sheikh Mujibur Rahman Agricultural University, Shere Bangla Agricultural University, Islamic University of Technology, Khulna Agricultural University, and finally Joshua University of Science and Technology. And all the universities are works for SAIYN, and they create the network knowledge-based platform for teenagers and youth. SAIYN has a Facebook communication page. If you want to get real-time update, you can go through with this page. For any advice or suggestion, you can use chat box or provide comments in the discussion session. And finally, thank you so much for your patience.
Thank you, Tanjim Akhtar, for your nice and informative presentation on SAIYN. Now, for the main event. At the very beginning, we'll share a slideshow to get familiar with our judges panel and our top 10 teams. We'll also learn about the evaluation guidelines from this slideshow. Please let me share the slideshow. So this is the slideshow where we will get to know about the evaluation guidelines of our IDEA Competition 2021. First of all, we can see the evaluation criteria. Here we can see the total IDEA competition was marked out of 100 and it was divided into 3 parts. It was divided into 80 plus 10 plus 10. The 80 marks was for IDEA, which was evaluated in the first round. And in the grand finale, the IDEA will be evaluated once again for the presentation of the IDEA, and 10 marks for the popular vote, which will be given by the audience. These are our honorable judges. We can see that our judges panel are consisted of teachers from both universities. We can see that our judges are Dr. Muhammad Manjur Alam, Dr. Prashanto K. Kalita, Dr. George Sapar, Miss Maria Jones, Mr. Leighton Brown, Dr. Chayan Kumar Shaha, Dr. Rakib Hassan. Our judges panel already selected the top 10 teams from the first round, and they are given here with a sequence of presentation. They are already made their sequence of presentation, but I'll still announce the team names once again. The teams are Crop Curators, Anam, Aquatic Squad, Venture, Potato Harvester, Aqua Solution, Technomis, Tahmidul Karim, Android App, and Kishan. Please note down your sequence of presentation. And last of all, for the popular voting system, our popular vote link or Google Form link will be active and available for 10 minutes after the presentation of 10 teams. You will have to select exactly 3 teams and submit these in the Google Form. You cannot choose less than 3 or more than 3 teams from this Google Form. You will have to submit exactly 3 teams, and 10 marks will be awarded for the most voted team in later calculation. So this will be the evaluation criteria of our IDEA competition. I hope everything is clear. Thank you. Now, before starting presentation of IDEA, I would like to inform each group that each group will have 4 minutes for presentation and 1 minute for answering question. Judges may ask question if there is any. Now, it's time for the presentations. I would like to invite our first team, Crop Curators. And please, Team Anam, be ready for next presentation. Crop Curators, who will be present your IDEA? Please raise your hand so we can make you co-host.
Okay, Crop Curator, you can go ahead.
Thank you. Thank you, the host. Thank you for giving me the opportunity to give the presentation. On behalf of the team Crop Curators, my name is Mirajus SAIYN. I will be presenting the presentation on smart herbicide for vegetable fields. With your permission, I would like to share my screen. So can I go for it?
Yeah, you can share, please.
Thank you. Good evening, everyone. My name is Mirajus SAIYN. On behalf of the team Crop Curators, I am Mirajus SAIYN. I'd like to present you on our IDEA smart herbicide sprayer for vegetable fields. Before going to the presentation, I'll like to give a quick overview about our presentation contents. First, I would like to explain our backgrounds and then the methodology, and about the socio-economic impact of our idea. Then I will explain the output and outcome and the budget of our idea. At last, I would like to give a conclusion and give you the base overview. What is our current spraying methods and constraint? Currently, farmers are manually removing weeds by hand, and herbicides are also being applied to the entire field and keep them under control wherever it's possible. Spraying chemicals on the plantation crops method is ineffective, and it is also damaging the environment and human health. Herbicide spraying also on a weed also harms the population of birds, mammals, insects, and other creatures by altering the nature of their habitat. Also, the herbicide we spray, the farmer's spray, enters the atmosphere through the soil or plant application. During spraying or vaporization is the most dangerous sources of the environmental pollution. That our idea is to controlling the weeds that grow among the plantation crops. It's one of the most difficult challenges faced by the farmers and agriculture workers. So we have choose these 4 criteria that we will build a suitable, intelligent, and image processing system, which will help to detect weed precisely. Our objectives: the main purpose is to develop a smart weed management system to ensure precise herbicide application based on image processing techniques with real-time weed recognition system. So our objective number 1, firstly, we like to develop an image recognition algorithm for real-time weed detection. And our objective number 2, to develop a spot spraying system for precise herbicide application to the on-site site-specific detection. What is our methodology? First, we will capture weed image, the image of the weed, then we will process the image with Raspberry Pi, we have image processing algorithms. Then we will detect any site-specific weed. After the detection, we will actuate the spray mechanism. Later, you will find out how we do it. In this 2 illustration, you are currently seeing there's one of our modules. On the left side is the single module of our weed detection system. The whole module can be, with some modification, the purpose technology can be used in autonomous vehicles and power tiller tractor. As illustrated, many modules can be linked together to create a wider spraying area in the vegetable fields. In this way, our system can be deployed both in small fields or in larger fields. In this way, the farmers will have more flexibility with our system. What will the socio-economic impact of our system? First, the women may benefit from the smart herbicide management. We know that in our country, women typically do the difficult work like weeding, and something like this. In the system, the women will benefit from the herbicide management. The system can produce efficient quality and quantity. Currently, our herbicide management system is really inefficient, but with our system, they can increase production efficiency. We can minimize the adverse environmental effect and risk. In the first presentation slide, we have shown that our current weed management system affects the birds, their natural habitat, and many useful insects. With this, we can reduce these effects. Then we can reduce herbicide contamination of the environment and energy. What will the output and outcome? Appropriate digital imaging system can classify the weed from other parts in vegetable fields. We have developed a system that can easily detect and precisely differentiate between vegetable and weed. So we can detect weed from a smaller quantity to larger quantity. It will be an innovative and site-specific spot herbicide spraying system to ensure precise control of the weed in the vegetable fields. Our outcome, it will be with our system, the outcome will be 2.6 to 3.6 times target efficiency. And we have calculated that for reduction, we can reduce non-target deposition to 70 to 90%. With this outcome, our system will be very much efficient and economy. What will the budget? We have calculated that in just 3,600 to 930 taka, we can build a single module. Note that this estimated costs are calculated in only for the computing part and spray mechanism based on the current market rate. And finally, we have shown that an intelligent weed management system based on real-time weed detection is expected to be developed. And When the system is implemented, there will be an increased likelihood for detecting and eliminating weed plants, even when the weed plant is too small and to be seen in the naked eye. And thanks for your attention. And if you have any question, you can ask me anything about this project or system. Do you have any question about my presentation or my ideas?
Judges, if you have any small question or comments, if not, sir, please. Okay.
Can I ask a question?
Please, please.
Yes, yes, yes.
Yeah, just because you asked me to ask a question, so that's the reason. Very nice presentation. Thank you. Thank you.
Thank you,
And congratulations. So will that weed be identified under, different crops will have different type of weeds. So how will that work? Is it the weed for the rice or weed for the beans or for which crop? Because sometimes, the weed for, like, for example, here for corn, our weeds look like rice plant. So how will that your machine or your software identify that?
First of all, I would like to mention you that we have our main idea is to detect wheat in vegetable weeds, but with proper image recognition system, we can create a system that can detect wheat even in crops, even paddy fields, wheat fields, as you have mentioned in jute, anything. And we can train this model with your specific requirement.
Thank you.
Okay. Mashur, please go into the next one.
Thank you very much, Team Crop Curators, for your presentation. Now I would like to invite Team Anam, and please raise your hand for who will be presenting so we can make you co-host. And please, Team Aquatech Squad, be ready for next presentation. Team Anam.
Thank you. I'm Iman Siddiqui, and my partner MD Mamun, both of student of Farm Power Machinery and Faculty of Agriculture Engineering, Bangladesh. Our mentor is Dr. Abdul, Professor, Department of Farm Power and Machinery in Bangladesh, Agriculture University. Our idea is aerial networking for agricultural management, and I'm in Bangladesh. Bangladesh is lagging behind in agriculture sector because there is a lack of mechanization in this sector, problem related to excessive use of pesticide, irrigation, nutrition deficiency in crop, etc. faces by the farmer in crop production. This problem can be solved by using modern technology at farmers level. Drone can meet this problem. Agricultural drones are applied to the farming in order to help increase crop production and monitoring crop growth, but drones are very costly for the farmer, where 84% of them are marginal farmer. Of them cannot afford to buy a drone for agricultural purpose. The aerial network for agricultural management and aims to add to make sure farmer to be benefited by services of drone necessary for agriculture without buying any drone and increase their production. Main objective of this idea to ensure emergency agricultural services with minimum time and cost, to ensure optimum use of agricultural input, to increase farm productivity, reduce production cost, to reduce pesticide in crop production to optimize use of the fertilizer. The main methodology of the idea, first of all, we have to build a control hub and Android app by which farmer can communicate with the control hub. Farmer will be able to.
Okay, can you put in a slideshow mode? And we can show the next slide, please. And be precise.
Sir. Methodology, sir.
Please go ahead. We cannot see your slides, but just go ahead. Put in the slideshow mode. Yeah, now we can see. Please.
Sir. Sir, we can see. Sir, I can start.
Yeah, please, very quick.
First of all, we have to build a control hub and Android app by which our farmer can communicate with the control hub. Farmer will be able to order necessary agricultural input as herbicide, pesticide, insecticide, and so on. A drone with a required input will reach the farm for the nearest substation. The drone in the field will capture images of the crop farming using camera sensor installed in the drone. Then the drone will process and analyze the image to find out the target area, nutrition deficiency, fungal, and so on. Using image processing software, this processing data from the image will be find out the type of problem to be solved. The artificial intelligence software will decide the type of problem and determination that application rate of nutrient, pesticide, and insecticide, so on, so that they can decide when and how much input is necessary. Farmer will be able to ensure the payment for the mobile banking and account like bKash, Rocket, Nagad, etc. For the provided services. Here we show the block diagram of Anam Control Hub. Here, mainly Anam Control Hub is divided into three parts. There is planning, monitoring, and controlling. Here, any farmer select for order such as farm service, pesticide application, and so on. So we can image processing and so on. We can cover and then decide our rate of application and back to the Anam Control Hub. Here the block diagram of the whole procedure we can provide. Now the market of that product, almost 25% increase in income probable in the drone in the field of agriculture. So we also use, for an example, fertilizer of in manual operating fertilizer, 9,000 taka per hectare. If we using our drone, then 40% of saving of fertilizer, our cost is very low, 5,400 taka. If we can fly 150 hectare in one target, that the difference between manual and drone, that 5,40,000 taka in one season. From this above information, if we think our country drone will be a great technology.
Please be quick. We are running out of time.
Okay. Then output and outcome of the presentation of the crop production will be increased, time will be saved, farmer will be benefited, and then they can run other business. Fertilizer can be applied properly in pesticide can also be reduce environment pollution due to the minimum uses of pesticide. Main sustainability, drone can scan large plot at on glance, 50 to 150 hectare in one flight. As a result, it can gather all the information of selected land. Farmer can have this information and able to understood the best way of using land for the crop production. The ANAM app will also analyze the field and it will suggest farmer for the better solution. Farmer will be able to apply the necessary inputs through the drone in the hand to red phases. Farmer don't need to buy any drone. They will have to pay for only the service provided. Control hub will be benefited because about of 60 to 90% less pesticide is required. So now farmer can get profit because of advantages of using drone and able to make control herb. The socio-economic of status will be high for the using of drone. Concluding of this idea, Bangladesh government has announced the National Agricultural Policy 2020. The government has given maximum importance to agricultural mechanization and IT sector for the fourth industrial revolution of the opportunity that could change the environment in way human think and work. The farmer and industry should importance innovative technology move very fast. The drone could be the application of both the agricultural mechanization and IT sector, and it can fulfill the national government goal. Farmer can improve their livelihood using drone technology. So this is our idea. If there is any question, please ask us. Thank you so much.
Thank you, Imran. Actually, we are already in our time, so maybe we can go for the next presentation. And if you have any question, participant, please ask our idea competitor in the chat box, please.
Thank you very much, Team Anam. Now, Team Aquatech Squad will present and Team Venture will be the next one. Please, the presenter of Team Aquatech Squad, raise your hand.
Please Aquatech Squad. Aquatech Squad.
Sir, one person has raised his hand.
It's a 2005004. Are you Aquatech Squad?
Yes, sir. I am.
Okay, please identify yourself.
Sir, I am from. Sir, myself is Mahadi Hassan, sir.
Okay, please go ahead.
Yes. Thank you, sir. Sir, sir, is it okay, sir? Can you see the presentation?
Yes, yes, we can see it.
Yes. Welcome to our presentation. We are the Aquatics squad from Khulna Agricultural University. Myself is MD Mahdi Hassan. I am going to present an idea, which is an automated solar powered aquaponics system. Overpopulation growth is causing more consumption, which has affected the land use competition between agricultural crop and fish farming. Aquaponics can be a smart solution for margining the land, well as meeting the protein demand of people. Aquaponics refers to the cultivation of fish and plants together in constructed recirculating ecosystem, utilizing natural bacteria cycles to convert fish waste to plant nutrients. Here the background of our project, but there are still some shortcomings of aquaponic system. Rarely replaced tank water increase the pH and temperature of the water. Continuous aeration and irrigation is required for maintaining the fishes and in proper condition. Therefore, automation by controlling pH, temperature, aeration, and irrigation in the aquaponic system can overcome these problems. But automation system may require a lot of energy, which can be supported by solar power. Our objectives, those are to monitoring and control differing parameters automatically of an aquaponic system, to power up the automated aquaponic system by solar energy. Here, methodology of our project. Our proposal for automated system for aquaponics will be focusing on monitoring and controlling several parameters using solar power. As you can see here, our main focus is on solar power, which will power up the device, and all the data will be acquired by sensors. Beside that, we have a microcontroller to regulate the environment. And this is how our automated solar power will work. And the whole part will be categorized as data acquisition and controlling the environment. For data acquisition process of automated system will use 6 sensors for measuring pH, dissolved oxygen, temperature, water flow, current, and voltage. For controlling environment, we have used microcontroller, Arduino Mega, and Raspberry Pi will control the total function. And the function of water circulation pump, chemical water pump, Peltier element, water heater, aerator, and all the information basically displayed on LCD display. This is the outlines of our project. Solar panel will harness energy which will transmit energy to all the system, and battery will store extra energy when it is required. We also we have also uses 3 sensor in fish tank, which send the information in Raspberry Pi, and this information basically we have seen in LCD display. Again, this sensor data will help to control water heater, Peltier element, and chemical water pump. And we have also data logging with the Raspberry Pi. Basically, data logger will be used for validation and data analysis. And we have also RTC basically used for real-time data collection. And this is our condition of automation. Tank water heater will turn during temperature less than 22 degrees Celsius. And when the temperature more than 30 degrees Celsius, then the Peltier element will be on and will be Peltier element also will be activated.
Yeah, your time is over. Be quick.
And pH less than 6.5, then the chemical pump will be activated and send calcium and potassium carbonate. And when pH level higher than 75, then also the chemical pump will be activated and adding in this fish pond, in this water, they added the phosphoric acid. And when DO level less than 4 milligram per liter, then we will switch on the air zone. And it will be turned off when the oxygen level is more than 8 milligram per liter. Water circulation pump will recirculate the water between fish tank and plant continuously. Our energy calculation for our project, we have recorded annually energy consumption is 2,759 kilowatt per hour. And for this, we have used 6 solar panel of 30 watt capacity are recorded for the total system. The socio-economic impact of our project is grow enough food and nutrition, grow expensive rare food independently, and reduce labor. And output and outcomes of our project is basically increase the yield through automation and controlling through IoT project, and use of clean and renewable energy to reduce energy cost and global warming Our estimated cost for the whole project is BDT 2.60 lakhs. This system may be beneficial and have good return in the long run. Aquaponics has emerged as a bio-integrated and sustainable food production system. The water quality parameters which increase the fish survival rate and can be controlled automatically by this system. I have one question for all present good souls. Will Bangladesh achieve her best in the aquaculture sector? If it is not, why don't we, the young generation, come forward to achieve the best in the agriculture sector? This is just our small effort to do something for our country. I hope our idea will be the unique and best idea. And thanks for listening my presentation. Sir, sign out from Aquatech squad. Please, sir, any questions, sir?
Okay, thank you. Dear judges, if you have any short comments or questions. If not, we can go for the next presentation.
Yeah, we can go for the next presentation.
Thank you, Aquatech squad, for your presentation. Now I would like to invite Team Venture for their presentation, and raise your hand, the person who will present, and Team Potato Harvester, please be ready for next presentation.
Team Aquatech squad, please stop your screen sharing. Abir Alam, please go ahead.
Good evening, everyone. Good evening, everyone. We are Team Venture from Khulna Agricultural University. My name is Mohammad Abir Alam, Faculty of Agriculture, Engineering and Technology. On behalf of my team, I came here to present our idea, Smart Monitoring System for Drying and Storage of Grains. Our project contains this point: background, objective, methodology, budget, expected income, and conclusion. As an agriculture engineer, we all are aware of the fact post-harvest losses. Food and Agriculture Organization, FAO, estimates that post-harvest losses can reach up to 20% for cereals, 30% for dairy and fish, and 40% for fruit and vegetables. The conventional method used in our country are based on manual observation. So a combined moisture, temperature, and humidity monitoring module can help farmers to overcome the post-harvest related problems. The purpose of the device will be a solution to measurement steady data in real time, then show it in a LED screen and as notification on mobile application. The decision to take necessary action can be made after observing the situation. There are two objectives of our project: monitoring grain moisture content, temperature, and relative humidity continuously during drying and storage operation. Developing a system for notifying the condition of drying and storage at any moment. Now I'd like to describe the mechanism of our system. The sensor and instrument required for the process are capacitance sensor, temperature sensor, humidity detection sensor, Arduino UNO board, Wi-Fi module, and LCD monitor. Moisture sensor, relative humidity detection sensor, and temperature sensor used to detect the data present in the grain and surroundings. Arduino UNO board will be connected to the moisture sensor, temperature, and relative humidity sensor, and Wi-Fi module will be used to connect the whole system with the mobile or laptop using Blink application. The app will give notification to the user for the supposed activity. The sensor will collect data based on different parameters of the grain and display the condition of the grain on LCD display, indicating whether the quality is good, medium, or poor. The user can utilize such information to take the appropriate action to prevent wasting resources. There will be alert system which will guide the user for proper decision making. Here is the flowchart of our smart monitoring system. And here is the system setup in drying operation. And here goes the system setup in storage operation. The estimated cost of our project is approximately 3,250 taka. Economically, smart monitoring system will help the products to achieve a great value in internal and external market. By storing grain in proper way, temperature and weather, we can hold our grain crops for a long time. Grains quality, nutrition, color will remain perfect, which will have a higher nutrient value. The expected outcome: the single monitoring system for both drying and storage operation. It will be monitoring real-time data and make quick decision during drying and storage operation. And it will also be cost effective and more accurate system. In the conclusion part, we can see the conventional or existing technology is not either cost effective or accurate. By developing sensor based technologies, it can show more reliable result. Thus the post harvest loss can be minimized. If this innovation is successful, farmers will be able to move forward by adapting themselves to technology. This can be done with a matter of minutes, saving time, energy, and reducing post harvest losses. At last, I would like to thank all the judges and audience for your attention. Thank you.
Thank you, Abhi, for presenting your idea timely. Judges, if you have any question or comment. If not, we can go for the next one.
Can I ask a question, Dr. Saha?
Yeah, please, sir. Yeah.
Abir, excellent presentation and good timing. That's always appreciated when you stay within your time. Where are you gonna put your sensor? In the middle of the bag, in the side of the bag, in the top of the bag, in the bottom of the bag? What will be your sensor intensity?
Sir, in drying operation, we will set up moisture sensor and temperature sensor inside the dryer, and we will set up humidity sensor outside the surrounding environment of the dryer to receive the correct data.
Thank you.
Yeah, thank you. We can go for the next presentation.
Thank you, Venture, for your nice presentation. Now, I would like to invite Team Potato Harvester for your presentation. Raise your hand, the presenter, and please, Team Aquaphonic, be ready for next presentation.
Assalamu alaikum. Good evening, everybody. I am Mohammad Rajab Ali from Haji Muhammad Danesh Science and Technology University, Dinajpur. And my mentor is Professor Dr. Muhammad Kamaluddin Sarkar, sir. I am very honored to be here there to present my idea. We know that only mechanization can increase food production and secure future food. Welcome to my presentation. My presentation title is Design of a Tractor-Operated 3-row potato harvester with automated yield monitoring system. According to FAO Stat 2019, Bangladesh is the third largest potato producer in Asia. There is a huge labor shortage in potato growing areas during the peak harvesting period. Manual harvesting is slow and power tiller operated digger is not fast enough. So we designed a tractor operated 3-row potato harvester with an automated yield monitoring system, which will be very fast and harvest in a very short period of time. Here we can see the full poster presentation of our idea. Here are the main components of potato harvester. Here is the isometric view of the potato harvester designed by SolidWorks software. Here is the first separator, tractor P2 attachment with bevel gear arrangement, 3-point hitch attachment, chain sprocket mechanism, first elevator, roller separator, horn and width separator, and here is the yield monitoring system mechanism. Here, power transmission mechanism. Here is the working principle of our potato harvester. Blade cut the soil and conveys potato to the first separator. The first separator conveys the potato to second separator. In the second separator, the potato and soil drop into the roller separator. Horn and width will pass to the second separator to outside the machine. In the roller separator, the soil will be removed and clean potatoes will drop on the first conveyor. The first conveyor will lift the potatoes to the second conveyor. Second conveyor will lift the potatoes into the yield monitoring system, and then potatoes will go through by this on the collecting bag. Here is the power transmission system of our potato harvester. The designed potato harvester is an individual implement that could be attached and separated from the tractor with a 3-point hitch linkage. After attachment, rotary power will be supplied to the rotary shaft of the implement from the PTO. After receiving the power from tractor PTO, the power will be transmitted to the implement driving gear through bevel gear arrangement. From the driving shaft, power will be transmitted to roller separator assembly shaft through a chain sprocket mechanism. Another two chain sprockets are attached, of which one of the first separator shafts separate the soil and the other one second separator shaft that separate horn and width. Those gets power from the roller separator. Worm gear separate the first conveyor that takes power from the horn separator. Here is the chain sprocket mechanism. Here is the yield monitoring mechanism. In the yield monitoring mechanism, there will be an impact plate attached to the end of the second conveyor. When potatoes will come from the second conveyor, it will make a force to impact plate, and two strain gauge load cell will be attached with the impact plate, which will convert the force into electric signal. A 4-channel junction box will be attached to the load cell, which will accumulate electric signal. Finally, a display console will be attached to the junction box. After processing and calibrating the electric signal, the display console will display total yield.
Your time is over, please.
The expected outcome. Yes, sir. If we use this type of machine in our agricultural field, there will be no need for further waiting after harvesting. Time saving will be 80% and cost saving 60% as compared to manual harvesting. We'll solve the problems of labor shortage in peak harvesting period. Farmers will get better returns and motivate for potato cultivation. Total cost was estimated from the local workshop is about 1,60,000 taka for only harvester, and total cost for yield monitoring system is about 1 lakh taka. That's all. Thank you. Thank you, everyone.
Thank you, Rajabali. Dear judges, if you have any question or comment, another participant can ask question in the chat box. So, Mansoor, please.
Thank you, team for Potato Harvester, for your nice presentation. Now, I would like to invite Team Aqua Solution for your presentation. And the presenter, please raise your hand. And Team Technomis will be the next one.
Farhana, please go ahead.
Yes, sir. Thank you, sir, for giving me the chance. Good evening to all present here. I'm Farhana Chaudhary Turna, a student of Khulna Agriculture University, Khulna. On behalf of my team mentor, Dr. Mohammad Nazrul Islam, and other team members, I'm going to present our previously proposed idea for SAIYN Idea Competition 2021. Our team name is Aqua Solution, and the name of our topic is Design of Combined Fish Growth and Water Quality Monitoring Device based on a computer vision system. Now I am going to. Bangladesh fishing industry is a well-established sector contributing 3.61% to Bangladesh national GDP. In the context of the rapid development of aquaculture industry, monitoring the water quality parameters such as temperature, pH, and dissolved oxygen or DO are crucial as these parameters are affecting the survival of aquatic animal. Also, continuous monitoring of fish status is very important for managing the growth and health status. However, traditional measurement and monitoring methods involve extracting the fish from ponds and retrieving information such as species, length, and weight, which is not only labor intensive, but also these methods may stress fish. Therefore, with the determination of the development of technologies for monitoring fish growth and water quality simultaneously, we are proposing a novel device based on combined fish processing and wireless sensor network system. The overall objectives for this proposal is to develop an online monitoring device based on a machine learning to relate aquatic fish growth to water quality. To introducing a WSN system to monitor water quality parameters include temperature, pH, and DO. An image analysis algorithm will be developed to process images of fish to extract fish outlines data, for example, fish size. A relationship will be developed between fish growth and aquatic environment. Methodology and materials include 3 steps here. Firstly, extracting fish size and weight by image processing. We propose a dual underwater camera which will capture image of fish and then pre-process it, which means remove unwanted object and give a clear image of fish. Then from the image, with the help of coordinate calculation, size and approximate weight can be estimated. Then secondly, water quality monitoring by multi-parameter sensors. The 3 different sensors are temperature, pH, and DO sensors are responsible for collection of corresponding data. Finally, the design and development of IoT-based monitoring device. The working principle of proposed monitoring device is based on Internet of Things technology. Here, Figure 2 shows architectural view of proposed idea. It represents the system consists of 3 elements. First one is perception layer with data storage, transport layer, and monitoring center. The perception layer is deployed in tank or pond, which is responsible for data collection. Then the transport layer, which mainly contains core network and are responsible for the data transmission. Then the monitoring computer, which works as communication server and data processing center. It will accept data transmitted by the transport layer and will transport those data to database server in the computer. All this transmission will be achieved through internet. Then we hope that the proposed monitoring system will be great practical significance that can contribute to improve the aquaculture management system and increase the fish production. We hope that the proposed idea will come out with a novel, smart, and online monitoring system for fish growth without disturbance of fish, and provide real-time water quality data, which will help to understand the fish health, provide information on ultimate optimum time to harvest a stock, help monitoring the fish behavior, and reduce the labor cost and inconvenience managing the fish ponds. It is estimated that the overall cost for the proposed idea will be around BDT 5,80,000.
Rana, your time is over. Please be quick.
In conclusion, I would like to point out that we are proposing a smart IoT-based monitoring system in order to monitor on-time fish growth and water quality parameters of aquaculture ponds for enhancing the management practice in fish industry. And the use of this modern device could be beneficial for fisheries, aquaculture, farm managers, and they will be able to know about the water quality and real-time fish growth without disturbance related to conventional handling. This is the end of my presentation. Thank you.
Thank you, Farhana. Yeah. Dear judges, if there is any short question or remarks. If not, we will go for the next presentation, and we will have enough time to discuss after all the presentations. So thank you.
Thank you very much, Team Aqua Solution, for your presentation. Now I would like to invite Team Technomis for their presentation. Please, the presenter, raise your hand. And please, Team Tahmidul Karim, be ready for next presentation.
Nishat, you can go ahead.
Yes, sir. Good evening, everyone. I am very thankful and honored for SAIYN for giving us such a great opportunity during this pandemic. Hope we are in good health. I am Nishat Taslim from Khulna Agricultural University. My presentation topic is about green roof farming and approach to cultivate capsicum in controlled rooftop greenhouse. At first, greenhouse, we all know about greenhouse, but rooftop greenhouse is not familiar in our country. So it will be a best option for cultivating capsicum suitable rooftop. This idea of cultivation capsicum in rooftop greenhouse demonstrate the potential of rooftop greenhouse and qualify the environmental, economic, and socio benefits. Our objective is to reduce the amount of cultivable land and to monitor and control parameters for the greenhouse. In methodology, there will be site selection, soil preparation, bed preparation, greenhouse installation, control environment, irrigation, and harvesting. Construction of a greenhouse. Our greenhouse will be a queen-seed greenhouse, and it will be in wooden structure. Polythene. We will use polythene for the cover. T5 and T8 LED tubes will be used for the light source at night. For bed preparation, we will use from one plant to another plant. The distance will be 1.5 feet. And soil preparation. If the soil is saline, at first we will use gypsum. Then we will use earthworm and compost manure. For installation of sensors and microcontrollers, there will be 4 sensors at the greenhouse. All the sensors will be connected with each other with a microcontroller. The microcontroller will collect the real-time data and it will send to the cloud database. There will be a server-side code in the cloud database, and when the range is above or below the preset data, it will automatically send SMS to the user's cell phone. For controlling temperature, we will use heater and cooler machine. Heater and cooler machine can automatically control the internal temperature of the greenhouse. There will be a heat lamp machine between the heater cooler machine and the greenhouse machine. Heat lamp machine can sense the temperature of the greenhouse, and this heater cooler machine will provide heat or cold wind to the greenhouse. For irrigation purpose, there will be a water motor and water pump, and you can also use rainwater for this purpose. And to store rainwater, we will use a reserve tank. As the use of sensors and microcontrollers is not familiar in our country, this process will bring a new dimension in agriculture. Besides implying a greenhouse on the rooftop, will retain the heat and keep the temperature cool in summer. Our expected outcome is to cultivate capsicum during off season. Will give a new dimension to our agriculture. This process will give more yield of capsicum and can be useful for other vegetables, for cultivation of other vegetables. Moreover, this process will bring technology closer to agriculture. For implementing the project, our total cost estimation is 18,025 taka. In conclusion, we can say that rooftop greenhouse are relatively new concept in Bangladesh, and this might be a great initiative. This process will not only be helpful, but also it will increase our agricultural land available for other cultivation. Furthermore, sensors and microcontrollers will assist the urban residents in receiving up-to-date data on their greenhouse. At last, thank you for hearing my presentation. I would like to thank USAID, Kenny State University, Alliance, and SAIYN Motors for giving us such a great opportunity for talking. Thank you.
Thank you, Nishat, for your time presentation.
Do you have any queries?
Judges, if you have any questions, please. Okay. If not, actually, we'll go for the next presentation. Mashood, please.
Thank you, Team Technovis, for your nice presentation. Now, I would like to invite Tahmidul Karim for your presentation. And please, Team Android app, be ready for your next presentation.
Amit, you can go ahead.
Thank you for the opportunity. Let me just. So, can you see my screen?
Yeah, please.
Good evening, everyone. I'm Tahmidul Karim, and on behalf of my team members, I'm going to present our idea on the topic co-digestion of rice straw with cow manure for methane-enriched biogas production in anaerobic condition. And we are from the Department of Chemical Engineering and Polymer Science, Shahjaal University of Science and Technology, Sylhet, Bangladesh. So I'm going to start with a brief introduction. So as we are using rice straw for our digestion process, so you all know that a huge amount of rice straw is generated in Bangladesh every year. And currently the annual production of rice straw throughout the world is 731 million tons. And 90% of this is generated in the Asian continent. And currently in Bangladesh, it is estimated that about 7.7 million tons of rice straw are rotten during the monsoon season. And similarly for cow manure, it is also estimated that about 3 million tons are generated every year. So if we can utilize this rice straw and cow manure for the anaerobic digestion process and produce biogas, then it can be a sustainable solution to tackle environmental and energy scarcity problems. And the reason we have chosen cow manure is because it has got high nitrogen content that can help in the digestion process and increase the anaerobic biomass activity. And so our main objective is obviously to produce, utilize rice straw and cow manure and produce biogas. And we also have a specific objective, and that is to optimize a hot water disk milling pretreatment process for the decrystallization of lignocellulosic waste biomass or rice straw. So here's our methodology or the process flowchart. So as you can see, we will start with the grinding of biomass using a wheelie milling machine, which will decrease the size of the rice straw to about 2 to 4 millimeter in size. And then we will go on to a hot water treatment process and then into a disk milling. The disk milling will actually increase the surface area of the grinded rice straw. And then we will mix that up with cow manure in different ratios in the feedstock preparation section. Afterwards, we will mix the inoculum. And for the inoculum, we have taken sewage sludge, which is very commonly available. And the reason we have chosen sewage sludge is because it is very high in bacteria or methanogenic bacteria, and thus it will help in the production of biogas. And in the main anaerobic co-digestion stage, it will run the process for 35 days at 37 degrees Celsius temperature. And the produced biogas can be measured using the water displacement mechanism. And also we can analyze the composition of biogas, like the content of methane or carbon dioxide, using the gas chromatographic method. So this is our digester setup. As you can see, in the left, we have a digester which is filled with biomass, mainly rice straw or cow manure, and the biogas that is generated will flow into this gas collector, which is filled with water. And as the gas exerts pressure, the water will be displaced into this water collector. So the volume of water that is collected in the water collector is actually the volume of biogas that is generated. And we also have a gas sampling valve using which we can collect the produced biogas. So the outputs and outcomes of our idea is that we can effectively manage agricultural wastes like rice straw and cow manure, and the biogas produced will help in the reduce the dependency on fossil fuels, and the digested biomass can be further used as fertilizers for crops. And we have done a rough estimation of what it would cost to set up a digester. So for a 5-liter volume digester, which has a capacity of 1 kg biomass loading, it would cost around 10,000 taka, or the equivalent amount in US dollars. And the biomass pretreatment would be around 5,000 taka, and the operation cost would be around 300 taka per day. So to conclude, our main target is to utilize the two abundantly available biomass, rice straw and cow manure, and co-digest those to produce a biogas, which is a renewable source of energy. And the optimized process will not only help reduce greenhouse emissions, but it will also contribute in the energy economy of the country. And the obtained biogas can be also used in the future as a potential transportation fuel, as household gases, and for further energy generations. So this is all from my end. I hope you have enjoyed the presentations. Thank you very much.
Thank you, Tamit, for your presentation timely.
Thank you.
So judges, please, if you have any question or comment.
Can I make question some?
Please use your chat box for questioning to the presenter. Only judges can ask now. So, and in the discussion session, of course, you can make comments. So please, we'll go for the next presentation then.
Thank you, Tahmidul Karim, for your nice presentation. Now, I would like to invite Android app, Team Android app, for their presentation. Please, the presenter, raise your hand, and Team Kishan will be the next one.
So, Haima Haidar, you can go ahead.
Can you see my screen?
Yeah, we can see.
Good evening, everyone, and good morning to the honorable guest from USA. I'm Haima Haidar Asha, undergraduate student of Faculty of Agriculture Engineering and Technology, Mymensingh. I'd like to thank you first, SAIYN, for arranging this idea competition. In this competition, my idea was about an Android app for estimating chlorophyll content in the paddy leaves using image processing technique. Now, I'm going to shortly describe about my idea. So first, why it is necessary to determine the chlorophyll content in the leaves. We know paddy is the main food grain in Bangladesh. For a good production, the basic needs are seed, fertilizer, and irrigation. Among fertilizers, urea is the most important fertilizer with highest nitrogen content. And nitrogen directly involves with chlorophyll content of a plant. So by determining chlorophyll content, we can know whether the plant is short of urea or not. And using excess urea is also responsible for water and environment pollution. That's why estimating chlorophyll content is important. Chlorophyll is responsible for the green color of the leaves, which is a good indicator of plant health. So in our project, we have tried to establish a relationship between the leaf color and chlorophyll content. Now, there are many methods to estimate the chlorophyll content.
Can you turn on your video, please?
Yes, sir.
Yeah, thank you.
Sorry, sir, I forgot. There are many methods to estimate the chlorophyll content, like Zelda tissue analysis method, chlorophyll meter method, like chlorophyll meter, but these methods are not suitable for field use. They are either highly costed and needed a skilled person for operating this. So our main objective for this study is to develop an Android app for estimate the chlorophyll content, which will be simple, easy to use, non-destructive, and real-time measurement. So for this experiment, first we collected leaf image. We collected leaf image from under different light condition and times of a day. And at the same time, we use a SPAD 520 meter for determining the chlorophyll content from the same point of the leaves. Then we transferred these images in the computer and analyzed these images. We took about 20 color features from these collected images, and these color features were used as parameters in the multiple linear regression model. Then this model will be implemented on a smartphone, and the app performance will be re-evaluated by using a new set of data. Now, what's the socio-economic impact? Like, as I said before, there are many methods for estimating chlorophyll content, but these methods are not suitable for field use or for farmer. Farmer needs a real-time application which can give them a result instantly. They can use this app for using fertilizer also. By using this method, environment and water pollution can also be reduced. Our possible outcome will be an Android app which can be very effective to measure chlorophyll content for the paddy leaves. This is our estimated cost, but once we have done our experiment, the farmers or the future users will not need any cost from there. And if our result is satisfactory enough, then this method can be a practical alternative method to measure the chlorophyll content of paddy leaves. And that's all. If you have any question, you can ask.
Thank you, Haimahedar Asha, for finishing your presentation timely. Dear judges, if you have any comments, please, or questions.
Sir, I have a question.
Who is there? Actually, we'll have a discussion session there. We can also ask, or you can use the chat box. We will have only last question, last presentation. So, Masur, please.
Okay, sir.
Thank you very much, Team Android app, for your nice presentation. Now, I would like to invite, last but not the least, Team Kishan for their presentation. Please, the presenter, raise your hand, and you will be given co-host.
I've raised my hand. I see that you've given
me
Team
Kishan, you can go ahead. Android app, please close your screen. Yeah, Team Kishan, go ahead.
Thank you. Is my screen visible? Excuse me, visible?
You have double. Okay, now we can see you.
Yeah. All right. So, assalamu alaikum and good evening to everyone present here. We are Team Kishan, representing our idea Kishan, the all-in-one gear Bangladesh farmers need. The members in our team are myself, Ahmad Al-Fayed Chaudhry. We have Fariha Fairoz Nuhan, Mohammad Sabir Rahman, and Fatamatul Johra Shanunda. We're all students of the Islamic University of Technology. We have been guided in our quest by Sabir Ahmed sir, who's a lecturer at our university as well. So before jumping into the idea, let us look at the scenario through the eyes of one of our country's agricultural workers, a farmer named Quddus Mia. In an interview, Quddus Mia told us about his misfortunes last year when rice blast damaged up to 70% of his rice fields, leading to a sum total of approximately Taka 8,500 in losses for a raw investment of Taka 12,000 per biga of land. Now, we have to understand that this is minus the cost of machinery and labor and so on and so forth. We also have to consider that for farmers who are struggling to make ends meet, between their own living expenses and leases that they have to pay on these crop fields, this is an incredibly burdensome amount. In another interview with Mr. Vishnu Shaha, Upajala Agriculture Officer of the Kushtia Shodor, he informed us that this is the story of thousands of other farmers like Kudus Mia, who are disheartened by the destruction brought upon by these leaf diseases like tongue row, bacterial blight, brown spot, etc., as well as pest attacks by leaf folder, whorl maggots, etc. According to Bangladesh Agricultural Research Institute and the Department of Agricultural Extension, as many as 104 different diseases affect cereal crops, who are also affected by 133 different pest attacks. The sad reality is that even in all the technological advancement that has come to us as a part of Industry 4.0, we have neglected the very people who ensure that we have food on our plates, our beloved farmers. In a nation where 37.5% of the workforce and 70.7% of the land are employed in agriculture, as per tradingeconomics.com, the simple scarcity of smart solution to these problems is absolutely unacceptable, especially considering the fact that simple early detection of these leaf diseases can save up to 100% of the crop yield, according to Mr. Shah. And so we present our idea, Kishan, an all-in-one tool for farmers. Kishan is a system comprising of an Android application and an optional set of soil pH, moisture, and temperature sensors to monitor crop land conditions. Abstracted from the view of the users is a cloud server that receives and processes data and sends out necessary output. From reports that we get from Mr. Shaha, as well as several well-established journal articles read on the internet, we identify 3 core areas where smart technology can improve crop productions. Number 1, early detection of crop diseases and pest attacks, as well as expert consultation. Number 2, regular monitoring and analysis of crop plans. And number 3, relevant tips and warnings based on weather conditions and zonal news insights. Now, Kishan lets farmers do all that from the palm of their hands. So, if a farmer suspects that some of his crops are suffering from diseases, all he or she has to do to get help is simply take a photo of the suspected crop on our application. Based on existing data sets and a very efficient state-of-the-art deep learning network, our cloud server processes and identifies the disease from the photo and provides immediate steps of action as suggested by experts. The application will also connect farmers with an expert from our team via a video call as required. We also have optional crop monitoring data from different sensors installed on croplands, which combined with our efficient prediction algorithm and machine learning techniques will provide farmers with pre and post cultivation tips, as well as real-time situational awareness. This will hopefully help them make the best decisions while minimizing their investments behind crop production. Optional aerial imagery that can be obtained via drones, for example, will also allow the system to identify affected zones and perform yield predictions, further benefiting farmers by letting them plan ahead. Farmers are also given useful tips and warnings based on the latest weather forecasts and zonal news insights to help them better shield their crops against calamities. Through our system, Kishan, we aim to provide these features to better equip farmers to make informed decisions and prevent financial losses. As a side benefit, we also hope to build a comprehensive database to further accelerate our research in the agricultural sector. Not only will
your time is over, please finish quickly.
Okay. Not only will these farmers be able to save on expenses invested in crop production, they will also be able to optimize their crop yield. We believe that this simple technology will be able to etch smiles across the faces of thousands of Kudus Mias and eventually lead to a happier Bangladesh. We have a demo that we've prepared that shows our system in action. So we basically have a web app that takes in an image and performs predictions on it. So this app basically tells us that such an application or such a project is incredibly possible, and it's going to be very cost efficient, and hopefully it will be a step towards making Bangladesh and its farmers very happy and very profitable with their businesses. So if we skip to the prediction portion, we see that the photo here is being uploaded. And once we hit predict, it shows us that this particular photo has evidences of bacterial blight with a 95.5% accuracy. Of course, this is a prototype and we're going to improve on it further. So that being said, we would like to thank all of you for your time and attention, and we'd like to open the floor for questions if there are any. Thank you.
Thank you, Team Kishan. So, dear judges, if you have any question or comments to Team Kishan. Okay, so Mashur, please, we can go to the next.
Thank you, Team Kishan, for your excellent presentation. And we'll wrap up our presentation session with this. So now, at this moment, Google Form for voting is available and active for 10 minutes on Zoom and the SAIYN Facebook page. You all are requested to vote for top 3 teams from these 10 presentations via the given link. It will be active only for 10 minutes, so please hurry up. Meanwhile, I would like to invite our SAIYN ambassador, Nibir Kanti Roy, to discuss on SAIYN activities.
Good evening, everyone. It is of my utmost pleasure to be able to talk here as a SAIYN ambassador. SAIYN is a platform for the youth to connect to the root system of our country, which is obviously agriculture, with technology-based and innovative approach. In present situation, if it's increasing day by day, so we need innovative ideas and technological support for the mechanization of agriculture, so that we can meet our production demand within the limited resources. Sustainable agricultural practices are an obvious need now, as we know that mechanization will increase the agricultural situation as well as reduce the drudgeries of the farm workers. We need to share this knowledge to the youth, and I think SAIYN would be a great platform to do this. The youth are going to be the future role players in upgrading agricultural technologies to ensure food and nutrition security, to enhance the process of smart farming, to enable mechanization. We need the youth for providing fresh ideas which we can bring into action. SAIYN will form a network where the students will be able to gain knowledge about the present agro-technological situations, and an awareness among them concerning sustainable agriculture can be developed. SAIYN will help to spread the necessities and importance of mechanized agriculture and smart farming among the youth, so that they do have a basic interest in this field. Thank you.
Thank you very much, Nibir Kanti Roy. Now, I would like to invite SAIYN Ambassador Abdul Aziz Khalid to tell us about your thoughts on SAIYN.
Assalamu alaikum, everyone. Thank you for having me included. It's a pleasure to be here. I'm going to be speaking to you today about my feelings working with youth organization SAIYN. To begin, I must say that SAIYN is a fast-growing organization and it will play an important role in our agricultural engineering sector. To me, SAIYN is not just an organization, it's a family, as it helps us to communicate with the respected teachers, students, and other important persons which are positive influential in our life. Because of SAIYN, we get motivations from our genius persons that cut off our depression through SAIYN. We get the update news and conditions of agriculture engineering sector, as we have the opportunity to communicate with the root people of this sector. In this platform, we can explore our knowledge and make it practical in daily life. Here, I have opportunities to complete tasks, which is very effective to explore our knowledge. Here we can participate in different competitions, win prizes, which can make a student motivated to pursue his ideas. It is a great organization where we can participate in different webinars and seminars to gain ideas about how to develop agricultural sector. This organization can help us to work for the sake of our people. I hope that SAIYN will go so far for the sake of human being, for the sake of Earth. Before ending my speech, I want to say that I want from SAIYN to teach, make practices by the youths and make them success for what we are dreaming for. Thank you all for your patience. I wish a very good evening. Assalamu alaikum.
Thank you, Abdul Aziz Khalid, for your speech. Now, I would like to open the floor for discussion and any questions for the teams and presentations.
Ladies and gentlemen, now the floor is open. I would request any participants, if you have any comments regarding the SAIYN or the today's presentation, please go ahead, raise your hand and present your ideas or any comments. Thank you. Professor B.K. Bala, sir, can you please unmute yourself and go ahead with your comments, please? Professor B.K. Bala,
yes,
he is a renowned scientist and is the teacher of all of us. And he has contributed extensively, especially in the post-harvest processing of the grains, the foods, the vegetables, the fishes, and others. He is the pioneer, especially in the area of post-harvest processing and reduction of losses. Sir, can you please go ahead, please, sir?
Oh, thank you for allowing me to say a few words. And first of all, my idea about the smart agriculture, I should say it is basically ICT-based automation. And first part, I mean that there should be sensors and control systems that should be developed. And the second is developed for optimization. And the next is the control that optimizations using some control systems that may be designed or that may be procured, that is already developed. That is the basic idea. This way, recently I published a book on a smart grid. That is the idea basically in case of electrical energy. But I think that holds for every system, that it should be modernized, automated, and ICT based. That is the main idea. But here some of the points I like to mention about the presentations. And one of the presentations, he has mentioned that green solar energy use can reduce energy. No, that is not correct. Solar energy, if we use solar energy, then we reduce the environmental impact. And it is a clean energy, green energy. That is why we are opting for it. Otherwise, no reason to avoid coal or natural gas, all these resources. And secondly, another problem I mentioned it, drone. Drone, it is, I don't know how it is going to be implemented. That is not clearly mentioned. But it is, when I was in Gopalganj, a lot of people are working on drone. But we are talking about the drone, and it is available technology, and everybody, some school students once came to me there, and Vice Chancellor sent him to that he has developed something. I told them this is not development. It has already developed. He has just assembled the portions only. And so but idea is there. If you can use it effectively, that is your own idea. Designing how you are going to design an express system so that you can place the insecticide or pesticide in the right place. And another thing I mentioned here, that is agriculture. Yeah, the first one on spray direct, that is a good idea. First one, first presentation, I don't remember exactly, but he has mentioned that will be a micro scale design. But that is a good idea in my opinion, and it can be, if it is properly designed, it can be effective. And although it is not totally implemented that much there in terms of at least theoretically, but the idea is very good. But second one, I don't think that is the. And about again the greenhouse, someone has talked about greenhouse. He has the idea is that he is talking about the cooling. Cooling is very difficult. you need a refrigeration system that is going to add another cost. So that is the main problem. You have to think about that. The cost, even I told you that you need to optimize. That means you need to consider the economy as well as the environmental impacts. And the another is in case of what is the rice straw. Rice straw nowadays is very much costly. Even in some, I mean, my own district, I have seen that it is like more costlier than the rice, because there is a lot of dairy farms. So if you are going and consuming that for diet by the animals, it's not going to create any environmental effect. I'm just making very short.
Thank you, sir.
So that is not the idea. That is not, should not be the idea. Another is the drying and processing. That I think that the measurement is already developed. That is not the idea. How you can implement this in a particular crop, that will be very much useful. For example, in our country, the onion storage is the major problem nowadays. This year there was a lot of debates over it, how we can save the crop. So they can monitor the two things you need to control: only temperature and the relative humidity. You can design something that can be optimally controlled. That is the all. And I have some more to say, but this is no time. So thank you for just allowing me to say a few words.
Yeah, thank you, sir, for your very valuable comments, and that will helps the competitors to conceptualize their ideas. So I know that Professor Alan Hansen and Dr. George Safar is also with us. So if you please just have some brief comment, we'll be really happy to hear from you, sir.
Well, thank you, Dr. Alam. I just want to commend all the participants. Very impressive, the range of projects that they have, very, very creative. I wish they could all win. They're outstanding. So thank you for the opportunity to hear some of your best and brightest students.
Thank you, Dr. Joseph. Professor Alan Hansen, please.
Yeah, so I would like to echo Dr. Zapar's message and say it's so uplifting to see the ideas that are being generated by the students to be able to solve, problems and think big in terms of getting problems solved. I think it's really, really great to see this happening, and this whole process of bringing the students together and focusing on developing these projects has a lot of impact, and I look forward to it expanding more in the future. Thank you very much.
Thank you, Professor Alan Hansen, for your very valuable comment, and that will inspire the competitors. I have seen that Dr. Anis Rahman actually raised some questions. If you have still to talk, so please comment briefly. Dr. Anis Rahman.
Sir, I am Anis Rahman or another?
Yes, you are.
Yeah, thank you, sir. Thank you, sir, for giving me floor. Actually, I have some queries to the team who show the idea of codization of rice straw and cow manure for enhanced biogas. Actually, I have some queries. What you show in the presentation, I am not clear. What type of digester would you use? Actually, is it base or continuous? If it is base, probably it will be base. If it will be base, of course, prior to starting your reaction digestion, you should mention the CN ratio of your mixer, of your digester, of the media. You do not mention the CN ratio of your mixer. If the CN ratio.
Yeah, thank you. We got actually the questions. Any response from the team?
Yes,
Please.
can respond to that because I am involved in that codization project. Yeah, thank you, Professor. You said we didn't mention the carbon to nitrogen ratio. That's true, but we are trying to maintain the volatile solid ratio and the total solid content of the biomass, and also the volatile solid content to the volatile solid content ratio of the inoculum and the biomass, so that the carbon to nitrogen ratio can't be in balance. I think that's the main query. If it is imbalanced by the carbon to nitrogen ratio, that can hamper the codization. So we are going to maintain the volatile solid ratio so that carbon to nitrogen ratio can be unbalanced.
Okay, thank you, Sadat Hussain. I know that might be some other actually communication between you and Dr. Anisur Rahman through the chat box. If any of the participants or any the ladies and gentlemen, if you have any comments, please go ahead and speak yourself. And we have might be some few minutes in hand, and before to when actually the result is ready, probably Masroor will let us know when it will be ready. So is it ready, Masroor, or we can go ahead for a few questions?
No, sir, we can have some more discussions. It will take some more minutes.
Okay, okay, please. Anyone raise some questions or comments, please? Yes,
Probably.
yes, please.
Probably, sir, we have Dr. Ayub Hussain from the Bangladesh Agriculture Research Institute, so we can hear from Dr. Ayub Hussain. Are you there?
That's it.
Dr. Ayub Hussain.
So, yeah. Later on, I know that you are always working behind and managing all the things. So could you please speak up, Mr. Layton?
Yes, thank you, Dr. Alam.
Yeah.
Thank you for inviting me to sit in on this on these presentations and for including me as a judge. It's been fabulous to see the great presentations and ideas that have come forth. Prasanta, or Dr. Khalid and I have already talked of how we can reach out to some of these students and potentially pursue these ideas even further. We're very impressed with these ideas and with the SAIYN program as a whole, and we thank you for leading this effort, both you and Dr. Saha. So thank you very much for including us.
Yeah, thank you, Layton, for your nice word. So I know that another judge from USA, Miss Maria Jones, is with us. So Maria, can you please speak up?
Thank you so much for this opportunity, Dr. Alam and Dr. Saha, and thank you for the privilege of being able to hear all of your presentations. I think it's amazing to see what all of you as students have come up with and the really brilliant ideas that we have seen today. We're really excited to be part of SAIYN and to help as the international mentors from University of Illinois Urbana-Champaign as a longtime collaborator and partnership that we really treasure with BAU. So thank you so much and best wishes to all of the student teams. I hope that even if you don't win, you will continue to pursue your ideas. Please do not give up on them. Youth are the future, so best wishes. Thank you again.
Thank you, Maria Jones, for your kind word. So ladies and gentlemen, you know that the youths from the different universities, they actually formed this youth network called SAIYN. And this platform will go ahead with new innovation, new ideas from the youths, on whom the future of Bangladesh actually lies. So we are at the advent of fourth industrial revolution. Although the Bangladesh hasn't completed even the second and third industrial revolution. So it's a very complex situation. But we have to cope with this smart agro-technologies, especially as Professor Bala mentioned that all the sensors are there. So all this artificial intelligence is there. So our IoT is there. So our new generation, especially the youths, they can actually cope with this blend of all this, the mechanical, electrical, and then, this digitized world into a complex ideas so that we can go ahead and we can cope with this fourth industrial revolution. As the government of Bangladesh is now planning to have some of this fund to allocate to the researchers, especially for the youths who have the creative mind, innovative mind. So that is an opportunity. That's all these organizations are going forward with these new ideas. So we are looking forward to the youths who can come forward and actually contribute with this innovative mind, with this creative mind, and that can lead us to cope with this fourth industrial revolution as well as the complex situation like Bangladesh. So we are really happy to hear from our young friends who have actually enlightened us. Yes, there are some ideas, there might be some shortcomings in the ideas, but these ideas will reshape and reformulate, and so that it can be a fruitful one to resolve these challenges of future agriculture and the food and nutrition security of Bangladesh. So thank you everyone for actually having with us and contributing with this, the whole gamut of this program. Thank you all. Masroor.
Thank you, Professor Dr. Monjur Alam, sir, for discussing about the idea competition today. Now it's time to know the winner of SAIYN Idea Competition 2021. I'd like to request Professor Dr. Prasanto K. Kalita, Director, Appropriate Skill Mechanization Consortium and University Distinguished Professor and Presidential Fellow, University of Illinois at Urbana-Champaign, USA, and SAIYN International Advisor, to announce the name of top 3 winner team. Please, Professor Dr. Prasanto K. Kalita.
Assalamu alaikum. Good morning. Good evening to all of you. It's a very hard decision to announce 3 top winners from a group of outstanding idea generators and presenters. First of all, let me tell you, all of you are winners. All 10 teams, everybody that presented, you are all winners. How amazing it is to sit down here first thing in the morning. This is Friday morning for us. It's your weekend time. I know it's fascinating to listen to some brilliant ideas by these young people. And I cannot express how touched I am by your wonderful ideas. Each and every one of you from different parts of Bangladesh, different your classes, undergraduate, graduate, and all out there. So first of all, I want to say congratulations to each and every team for presenting here and enlightening us with the brilliant ideas. However, there is always 0.1, 0.01 differences between these winners. So I'm not gonna tell you who scored how much, but the judges, all of you, they have selected, three top ones, and the other not top one winners too, but the 3 top 1 winners. Number 3 is, I also like that ANAM, the Area Network for Agricultural Management team by the wonderful Bangladesh Agricultural University. So that's number 3. Number 2 is the Aqua Squad, an automated solar powered aquaphonic system from Khulna Agriculture University. And you probably are now wondering who is number 1. And number 1 is the crop curators and the crop curators are smart herbicide sprayer for vegetable fields by a group of outstanding students, again, from our dear Bangladesh Agriculture University. So these are the three winners. Let's give all of them a big round of applause. But also, as I said, each and every one of the team that presented today are outstanding. So I congratulate all the three top winners and the other 7 winners for this competition. Thank you so much.
Thank you very much, Professor Dr. Prasanto K. Pandita. Now that we have found our winners, I would like to request Mr. Sadid Jamil, Managing Director, the Metal Private Limited, to express your overview on today's competition. Please, Mr. Sadid Jamil.
So is he still in? I know that he has some other programs. So initially he joined and probably left out, and once he mentioned. Is Mr. Sadid Jamil still with us? Hopefully not. I know that he has other engagement. Can you please go ahead with the next speaker, please?
Okay. Now I'd like to request Mr. Subrato Ranjan Das, Executive Director, SAIYN Limited.
Again, so far I know he has another meeting with this, the other group of people. So he's not with us probably, and hopefully in the future he will be with us. So go ahead with the next presenter, please.
Thank you. Thank you, sir. At this point, I would like to invite our guest of honor of the grand finale, Dr. AKM Zakir Hussain sir, Students Affairs Advisor, Bangladesh Agriculture University, Mymensingh, for his speech.
Thank you very much, Mr. Masrur. Grand finale event of SAIYN Idea Competition 2021 on Smart Agriculture on Green Planet. Honorable Chairperson, Professor Dr. Nazrul Islam, Honorable Dean, Faculty of Agriculture, Engineering and Technology. Honorable Chief Guest, our Reverend Teacher, Professor Dr. Lutful Hassan, Vice Chancellor, Bangladesh Agricultural University, who has given his speech earlier. Honorable Guest of Honor, our friend, Prasanto Kumar Kalita, Director, Scale Mechanization Consortium at USA, University of Illinois, Urbana-Champaign, USA. Honorable guest from abroad, especially Josh Schaffer, Leighton, Maria, and Alan Hansen, and our honorable teachers, guests from different corners from Bangladesh, and very good evening, and for USA participant, very good morning to you all. Actually, this is very important event for the young generation, especially for youths, on smart agricultural technologies. We know agriculture is certainly one of the significant activities of a country like Bangladesh, as it is not only feeds the million of people, but also contribute towards growth of the GDP. So at various social events, we know the university, college, this agricultural technologies innovation is a pertinent issue, and various steps are also taken by the government for improvement of this sector. And SAIYN has created an opportunity for the youth to involve in these issues. Especially today's this event, there are 10 teams have participated today's for presentation, especially the potato harvester, green floor, green rooftop crop creators, aqua squared anam, aqua solution, and diagram of rice, and Android application Kishan, and smart monitoring of from different university, like from BAU, from Khulna University, from Shah Jalan Science and Technology University, and Institute of Islamic Institute of Technology. And I became very amazed to see all the presentation from our young generation, especially on smart agricultural technologies. Originally, the innovation is, this is the more important.
Professor Dr. Zakir Hussain sir is probably disconnected. So should we wait or should we continue?
Just wait a few seconds so that if he can join, otherwise we can go to the next speaker.
Yes, sir.
So Masroor, you can go ahead with the next speaker, but if he shall actually come back with us and join with us, we can hear from you later on, okay, if possible. Go ahead, please.
Okay, sir, thank you. Now I would like to invite our guest of honor of the grand finale, Professor Dr. Prashanto K. Kalita, Director, Appropriate Scale Mechanization Consortium.
He had joined actually, Masroor.
So should we continue with Professor Dr. Zakir sir?
Yeah,
yes,
please.
Sorry, Masroor, for the interruption of internet connectivity. Sorry for
yes,
that.
Sir. Yes, sir.
Actually,
Continue,
what I say earlier that we know the innovation is more important than ever before. This sector is facing huge challenges from rising cost of supplies, shortage of labor, and chances of consumers' preference and sustainability. So that our competitors have presented their ideas, especially focused on those issues, how to help the farmers and how to create awareness of the farmers and how to help the farmers for adaptation of new technologies so that they can produce more foods for the nations. Actually, we are facing, we are fighting for the fourth industrial revolution, is especially changing the globe already, and Bangladesh cannot left alone actually. So the use of modern technology is vital, obviously, in increasing the competitiveness with the others, and also the sustainability and digitalization are interlinked and complements each other. So what we came to know from the students from different universities, they have presented very good idea, and they those idea, I have some suggestions and recommendations for SAIYN. If we select those, especially 2 teams already selected as first and second, third, and what I see in the presentation, both all the participants, especially 10 teams, they have presented very nice idea for smart agricultural technologies. So I would have some suggestion to SAIYN. SAIYN already created a very strong network with the youth of the national and international to share the output for smart agriculture and technology. Obviously, I request SAIYN to increase this connectivity to not only Bangladeshi students, and also create more connectivity with the foreign participants, national and international. And SAIYN already create the awareness and sensitize and build the productive capacity of youth already in Bangladesh. I hope it will increase day by day, and it would have certainly create a great opportunity for the young people to explore their ideas for sustainable agricultural productivity. And obviously, SAIYN would contribute for achieving the SDG by innovating and discovering smart agricultural technologies, because we are fighting for, as I said earlier, that we are fighting for the fourth industrial revolution, and we are we have been facing many challenges for that sustainability. So the trained and person or trained youth from this SAIYN group obviously motivate or educate other young generation for this sustainability. And SAIYN would obviously develop capacity by identifying the social needs and do collaborative research with the others university or other young generations, and also do collaborative research with the foreign participants or foreign researchers, so that they have they can gain more knowledge and they can explore their ideas more efficiently. I would request SAIYN to create that kind of opportunity for our young students. And also actually all those discussion, obviously I should say that SAIYN would obviously that would enhance meaningful contribution on agriculture, livestock, fisheries to ensure food security. Especially our Professor Manjurul Amin said that we are fighting for now in nutritional security. You know, there are 4 SDG goals is directly related with the agriculture, and we are now 80% SDG, 80% contribution from agriculture on SDG. So we need to address those SDG goals, especially here there are 10 teams, their presentation, they actually focused on the rooftop agriculture, and we know the major technology innovation in agricultural sector nowadays focused on indoor vertical farming, automation and robotics, livestock technologies, modern greenhouse practices, precision agriculture, vertical agriculture, artificial intelligence, we know Internet of Things, blockchain, and big data, robotics, and there are so on many agricultural technologies now has been practices in different countries in the world, but we are also far behind to these technologies. We need to address those technologies in Bangladesh also, so that we need to include our young generation to provide them the opportunity to explore their ideas on those issues in Bangladesh. This is actually partnership with leading industry also and organization also very important. We know, you know, our Bangladesh Agricultural University was established in 1961, and from 1961 we are fighting and we are exploring our effort to increase the productivity, and we are working with the farmers in the field level. And what we discover our technology, we used to practice those technology with the farmers and in the field. May I request our SAIYN group, what the idea developed our students today, and we have selected the 10 teams, and already we have declared first and second and third teams. But I would request SAIYN to all 10 teams, their ideas, please help them to explore those ideas in laboratory level first, piloting, and then please this idea you suggest the students and involve the suggestion to the farmers level, so that this idea can be sustainable for our agricultural productivity. And our university also, we are trying to do some research with the industries and academia for better for getting the better result, and also explore the idea to the others also. And also we have developed our course and curricula focused on industry and academia linkage. So finally, this is all about my speech, and I would like to thank the organizer, especially our Professor Manjurul Alam sir, the Chief Advisor of SAIYN, who have who has contributed a lot for the young generation, especially the young people who are working on agricultural sector and who have the intention to do something for agricultural development. And also I would like to thank Professor Chayan Kumar Saha, the National Advisor of SAIYN, and also our university level as an advisor of Student Affairs Advisor. We are also exploring some effort to engage our students to do some of those idea competition also, and also some social activities also. And so we need to include the students and some of the idea sharing with the farmers. You know, we have already installed the Farmers Day in our university. We hopefully will celebrate the Farmers Day on every year, and that day we need to show our idea and technologies to the farmers also, so that they can have some influential idea, and farmers can know about the new ideas, so that they can explore in the field of those ideas. That's all today. Again, I would like to thank the organizer and our guest, our chairman of this session. And I see the VK Bala sir, our reverend teacher, very senior teacher now here. I see sir is very good health right now also. And I wish all of you your good success and also good health also. And our colleagues from abroad who have joined today's program, I just thankful to them from our university side. Please visit our university and let us do some collaborative research with our young colleagues and young generations for the future, young generation for the future who have guided by us, and they will obviously contribute the agricultural development, especially for the development of our country. Thank you very much for your patience hearing. Assalamu alaikum.
Thank you very much, Professor Dr. A.K.M. Zakir Hussain, sir, for your inspiring speech. Now, I would like to invite our guest of honor of the grand finale, Professor Dr. Prashanta Kumar Kalita, Director, Appropriate Scale Mechanization Consortium, and University Distinguished Professor and Presidential Fellow, University of Illinois at Urbana-Champaign, USA, and SAIYN International Advisor for his speech regarding today's idea competition.
Thank you, Dr. Masoor Ahmed Bhuiyan, Chair for this grand finale. First of all, lots of people are in order for thanks. I'll start with Dr. Alam and Dr. Saha, our ASMC country coordinator and director for ASME for Bangladesh and co-director. This was like a dream of us when last year we had a discussion about forming a youth network similar to or following or in a philosophy that we have 4-H youth network, and it was beyond my imagination that within such a short period of time, SAIYN was formed. And now look at that. Here comes one of the outstanding or the very impactful outcome of this ASMC/ASMIH and slash all the other our administrators and contributors in the food, nutrition, agricultural, engineering, and technology sector. So thank you all. I'll start with our honorable Vice Chair, Dr. Lutful Hassan, who always has been an inspiration for this project. For us, I am very sure for Dr. Alam, as well as for us at the University of Illinois, he always participates and encourages. So his continuous blessing and support is always appreciated. I also like to thank our Dean, Dr. Nazrul Rahman, and Professor Zakir Hussain, the student affair person, for supporting this work that kind of laid the foundation of sustainability. Dr. Bala is so nice. We are very grateful that you are here. You're able to spend your precious evening time. Oh, for you, every day is a weekend now because you're retired. But still, thank you for your participation. I also like to thank all my colleagues here at the University of Illinois. Several of them are participating here. This is our core group of people that everyone participated, from the looking at all the written reports and being judges and giving their comments back. So thank you so much. And all of you, all the participants, at one time we noticed there are close to 240 participants today. And so it shows what a great interest you have in the youth network, and the youth network then that will change the agriculture for the future. And as you know, this is the digital era, and digital agriculture is one of the buzzwords, and that's one of the key mechanisms to involve our youngsters, our youth, for any of the thing that we do future. It's not only in agriculture. I think in all the other disciplines, in all the other areas that have posed our grand challenges to all of us: food, nutrition, water, education, and everything else out there. So thank you to all the young people, all the youth from all different universities of Bangladesh that have participated, came up in such a short time. You all came up with brilliant ideas. All these ideas are so good. I would also request Dr. SAIYN Saha to enlist all the ideas, the ideas that have been presented today, and other ideas that were not presented today, but on the written reports that they had, to put in our ASME website, so that there is a permanent record of these ideas. And the ideas, new ideas, will grow from these ideas, and eventually they will take off in a form of real application of technology. Lots of technology will be developed from that. As I have listened through all the wonderful presentations, starting from chlorophyll, aquaponics, Aman, networks, potato harvester, and all that thing, each and every one of you have done a wonderful, you have gone through wonderful thought process with the cost, with the ideas, with the limitations, and most importantly, how farmers will benefit from that. Food and nutrition that's our responsibility, right? The thing that how things can get sustainable, all the technologies that you have put it out there, that we all need that. But most importantly, what we need is you, the youth, the young people. You are the driver of sustainability for our future. So, the technologies will come, technologies will be enhanced, technologies will be applied, will make life better, life and livelihood for all of us. But without you, we will not be able to do any of these things. So the matter of fact that we have now so many universities in Bangladesh, we have our branches of SAIYN, or the main branches of SAIYN, and you all are enthusiastically participating. That itself is a wonderful sign that our future, Bangladesh's future, and the future of our globe, for not only in ag and food and nutrition and water, but in the entire domain of our humanity, that is very obvious. So thank you so much for you participating and sustainably keeping this thought process, bringing new ideas and sharpening through your ideas and making it work. This is only the beginning. This is only the beginning of idea formation. And then we will also, Dr. Alam is one of the greatest leaders that I have ever worked with, and who make things work for people not only in Bangladesh, but also he's providing a lot of help to all our international partners. So your ideas that you have generated, we would like to make sure that everybody knows about these ideas. And these are global ideas, global innovation network. You have proven yourself with your dedication and brilliant ideas that you can work together. You all work in a team. And I always, when I teach about team, I always say, anytime when you work in teams, you know, there are 5 components in a team. First, you form a team, and then second, you storm. That means you all fight with each other that this idea is better, or that idea is better, or that idea is good, that idea. And then, you know, everybody's good things start coming out. Third is norm. Then you all settle down. We all agree what kind of team effort we are going through. So form, storm, norm, and the fourth is perform. That's when we all agree, then we perform. And the latest literature added the last one as adjourn, like you put conclusion to that. And that's a wonderful way for you all, the brilliant young minds, to work together in a team and respecting each other, listening to people out there. And I would also like to see that these teams that have participated today and others that haven't participated today, we will provide through ASME a platform for you to interact with each other. And, you know, in a positive way, criticize, criticize is not a right word, but I said in a positive way, critically review each other's project to make it better. Because, you know, when my neighbors are better, I am better, right? So that's the message that I wanted to give it to you. Again, thank you so much. I really enjoyed this, the presentation, and I look forward to wonderful things that will come out from this work and many more work through you, through SAIYN. Thank you so much. Assalamu alaikum again.
Just one small announcement before going to the last speaker. Just for your information, actually, that we'll have a regional workshop in this month, and all top 10 ideas a team will be given certificates, and top 3 idea will be awarded with the prize money, crest, and certificate. So that means we are recognizing all the top 10 ideas. So again, congratulations to all the team for your patience and participation. Thank you.
Thank you very much, Dr. Prashanta Kumar Kalita, sir, and thank you very much, Chayan Kumar Saha, sir. Now, time for closing remarks. I'd like to invite our session chair, Professor Dr. Muhammad Nazrul Islam, sir, Dean of the Faculty of Agricultural Engineering and Technology, Bangladesh Agricultural University, Mymensingh, to deliver his speech and conclude this session. Wish you all very good night. Good day to our guests from USA, and goodbye from my side. Please welcome Professor Dr. Muhammad Nazrul Islam, sir.
Good evening and good morning to everybody. I would like to thank all the participants of today's grand finale of SAIYN Idea Competition on a smart agriculture for a green planet. And it was really a fantastic program, and I enjoyed the program actually. So the idea of this competition, I think there were 90 ideas, and out of this, the judges, they have taken 10 top ideas. And the universities participants were from BAU, it was 3 participants out of 10, and Khulna University, they were 4, and 1 from Haji Danesh, 1 from SAST, and 1 from IUT. So the presentators, they have presented very nicely, and the ideas are really fantastic. As Professor Khalid said, really, the students, they have come with good ideas and innovative ideas. So their presentation was really nice. So one thing I should, and another interesting thing I should say, the Khulna University, it is a new university actually, but they have come with four ideas, and that is it. And that is really interesting. So I will actually I want to thank the organizer, that is Asim Bangladesh, for for organizing this competition. Also, I want to thank the Sustainable Intensification Innovation Lab, Kansas University, and Feed the Future USAID for financing. And I will ask SAIYN to organize this type of program in future also, so that our students, they can be engaged with new ideas also, and they can they are engaged with this type of programming and this type of apps. So I would like to thank Professor Dr. Prashanto Khalid. Actually, he's the main, that is the idea. This idea, I think, came from Dr. Prashanto Khalid. And so I want to thank him. And also I want to thank the organizer of this total competition. And they have given a lot of efforts to come to this today's achievements, actually. So I would also want to thank our chief guest, Professor Dr. Lutful Hassan. He has given time. Actually, he was so busy. Even he was busy, and he was going to Dhaka also. But he has given some time, and he has given a speech. And I also want to thank our advisor, and he has given a good speech. And finally, I want to thank Professor Munjurul Alam, Professor Chohan Kumar Shah, and his team. So actually, they have done a good thing. And also, thanks for giving me a chance to say something and share the session. So with this, actually, I want to conclude today's program, and thank you all. Good night.
Thank you, sir.
Yeah, thank you. So thank you, everyone, and especially our friends from USA.